Good afternoon, everybody, and welcome to the first meeting of the Mind session of 2021. And we have a very special session today about computer science and information technology with Dr. Christian Turing, who is professor of computer science at EPCC. The idea of the Meeting of the Minds series to allow professors to talk beyond the classroom in a very free and sophisticated way about their subjects of expertise. I feel this is very important for both the professors and the students because the students get to see the range and the potential of the courses that they're taking and even majoring in. So you'll hear a level of conversation between the professors on the panelists of all the Meeting of Minds sessions that allows you to see just how interesting and imaginative and creative all fields can be, and might even make you want to study or even major in a field that you may not have thought of before. So today is very timely because, as we all know, computer science, information technology, social media is essential to all of our lives. So let's begin. First, Dr. Savine, please tell us about your background and what made you want to become a computer scientist.
Hi, everybody. So thank you so much for joining us, and thank you, Professor Richard, to allow me to be here. This is a great space where we can share this thing. So your question is what is my background and what made me realize to computer science? Let me just give you a couple of my background, which is a little bit weird because when I started my studies, I started as a music major. That was my primary major. I started at UTEP a long time ago. And then I changed gears to a field called philosophy. And people say, what's related with computer science, philosophy, and music? Well, back in the day, I didn't know what to do. Well, I still don't know what to do with my life. But one of the things that I was actually questioning is I like music, I like philosophy, this part, and then later on I realized what was this computer science, which is a very fantastic field and attractive field in the way you think. So if you think music and philosophy, they have a lot of common, which is an analysis. I know philosophy might break into two different venues, continental philosophy and analytical philosophy. So there is some common ground between areas that actually I study. When you go to computer science, you realize that you might want to use a computer in order to solve problems, but in reality, what you're doing is to do critical thinking. And that's what I decided to study computer science. Then I got recruited to continue with the master's program. So I was very lucky to work with a lot of people during my undergrad and then eventually to my graduate level. That's where I finished my first master's back in the day it was called computer security. So I have a master's in cybersecurity. But later on, I continued to work. I was very lucky to work with one of my great mentors, Professor Nosvich at UTEP. So that basically brought me to the next level, which is the PhD. So eventually I finished my studies in computer science. So I'm a computer scientist by training, but I have a specialization on computational science or data sciences with a lot of with a topic called fuzzy logic and uncertainty quantification. So I know it sounds very weird, all that stuff, but basically we're trying to measure uncertainty in certain aspects. So the best way, actually, the common ground that I find out is try to teach this stuff into the new generation. So that's what I've been doing here. Eventually, I was an EPCC student back in the day, so I'm an EPCC graduate. And I always was very close to El Paso Community College. So when I went back to the college in 2008, I started to teach classes. So I've been there since then. I've been here at EPCC.
Thank you, Dr. Savine. And I just want to let the audience know that if you have any questions, there'll be a question and answer period at the end of the session. So if you just jot them down or keep them in mind for the end of the session. Dr. Savine, what abilities does a student need in order to be a computer scientist? And in what ways can he or she use a computer science major?
Yeah, and that's a great question because we don't know really. many people, when you talk about computer science, you might think, well, you need to be a geek, you need to like computers and video games, and you need to know a lot of math, which is not really true. So we have different types of students. We have students coming from high school that they already know a lot of information about computer, which is great, congratulations. But in the other way, we have students who already graduated with a major, art, biology, maybe some kind of science or mathematics, and they come here and they try to learn something that they can apply. As you already know, and you already mentioned, computer science is pretty much everywhere right now. So everybody, right now, you're watching this video in a mobile device, in a computer, probably in this platform that is thanks to the advances in computer science. So the question is, what kind of qualities you need to know in order to come here to computer science? You need to like some kind of communications. You need to like technology, of course. But you also need to know how to solve problems. I think that's the most important aspect. If you know how to solve problems, then you can apply it to whatever area you want. It can be computer science, it can be mathematics, it can be art, it can be digital art, it can be even clinicals and whatnot. So many people, they might see that there's a completely separation between computer science / IT in the real world, and it is not. Computer science is basically, we solve problems, but we use the computer and we use programming languages in order to solve those problems more effectively. And that's why we're trying to give different variations of computing. We have the computer science, we have the IT, we have cybersecurity. It depends on the problem that you want to solve. You actually study computer science. So just try to finalize your question. What kind of attribute you need to have in order to go to computer science? You need to like to solve problems, period. If you have a mind where you want to just have a problem and try to solve it into different pieces, you're in the right track. And this is actually most of our students that we got. They're students who really want to solve problems through maybe in biology and maybe in chemistry, maybe in different areas. So that's pretty much it, what we can tell you right now. I will give you more of those concepts later on.
But essentially, it's a problem-solving field.
It is indeed.
Applied to all fields. My third question is, computers are a vital part of everyday life, as we all know. But have they fundamentally changed the way human beings view themselves and the world?
Mm-hmm.
What do you think?
Yeah, it's that's a great question, and the truth is that we have. I share a lot of conversations with a couple of colleagues of mine who study social sciences or they teach social sciences. Some of them psychology, some of them they're even in philosophy. So it is indeed something that have changed through time, because it started back in the day just a regular device, a big computer that was in a room, and you just work for certain tasks. Nowadays, everybody has one of this, a mobile device. Back in the day, we call it cell phones, but now it's not a cell phone, it's a computer. And people cannot, I shouldn't generalize too much, but many people cannot live without this right now. So people say, I'm anti-technology, and I really admire these people. But right now, especially because the whole situation that we're living in, we are very engaged to have one mobile device right next to us as a tool. It started as a tool back in the day, but now it's kind of like embedded attribute for us because we communicate with our family, with our friends. We have a social life via electronically, yeah. We share our thoughts by social media. We try to reach information by using Wikipedia or something internet. So everything has been embedded with us through this social media through the mobile device. So it's a little bit complicated to say that question if it has influence. The answer is absolutely true, because now instead of just say something to a person in the face, right, you probably send this indirect message through social media. In case you want to explain yourself to someone, you instead just send a tweet. Instead of just establish a real conversation with someone, you probably send, I don't know, maybe some chat or some kind of group in a messenger. You use some other platforms. So it is indeed, now we're living through those devices. Instead, back in the day, we used those platforms only to communicate or to perform tasks. Right now, everybody, we are in front of the computer. We are in something called Collaborate that uses institution that basically help us to teach. Yeah, so it's definitely something different. But you might said, well, we are in the middle of an emergency, international emergency. We have to have a mobile device or something like that. Yes, indeed, we have to. But we don't really have to actually accommodate to those needs. Although there have been very improved. I remember when I was taking a class back in the day, the very first online classes has nothing to do with the courses that we're taking right now, or something, this interaction that we can see right now. They are very, very different.
I now want to move from the use of computers in everyday life to information technology and social media more broadly. Has the nature of modern society, late 20th, 21st century, and human socializing fundamentally changed from that of, say, previous to 1990? Mm-hmm. What do you think about that, Dr. Sabine?
And it's very interesting because the notion of technology, we always trying to accommodate to the generations that we're living in. It's like, oh, this is technology. But back in the day, technology has been always in every century, in every single moment of life. So it's basically an advance that people can actually take it to their advantages. I remember when the internet was becoming popular, people say, well, that's a very good thing, but you shouldn't be going to the internet. There's horrible things there, and that's fine. I understand that there's horrible things, but there was also a lot of alternative things there. Back in the day, a refrigerator was considered to be technology. A microwave was considered to be a technology. And there's always this trade-offs about what to say is as a good or a bad thing. So the question is, has this modern society and human socializing has changed? And we have been adapted to the current technology. That's probably one of the clarifications that we need to do. We just adopt this generation to that. Back in the day, even before electricity, there was some kind of technology and the people, they use it. Fire one day was a technology because it was something new that was help us to get some heat. Yeah, eventually, even in more modern civilizations, when they discovered the telescope, that was kind of technology that realized what was going on, not in the same space that you were living. It's the same situation that we're living right now. Now we have the internet. Now we have a lot of social media, which everybody uses. And let me just tell you a little bit about this, because you mentioned the word humanizing. The humans right now, what we're doing is that we share all our thoughts or our activities. We check in, we log in, we like, we share, we comment a lot in through all these social medias. And the question is, who is keeping that data and for what reason? It's like, oh, at the very beginning, everything started like 10 years ago, like a fun thing. But later on now it becomes a little bit more concerning, because there's a lot of situations that can be a little bit intrusive. For example, I remember when I used Google a lot, right? For Google Maps, well, for a lot of different things. And then at one point I was at EPCC Valle Verde, and then I received a notification from Google to my cell phone. It's like, it's time to go home. So, okay, fine. How do you know it was time to go home? Because it actually was time to go home. Because I was, at that time, specific time, I was just closing my door and I received something like, it's time to go home. Like, how do you know? And then I went, I don't know, to pick up some Peter Piper pizza. And then when I get out, it's like, how was Peter Piper pizza? And what in the world, right? What's going on? So there's GPS, which is great to go find a location. But also it's a device that is a technology, it's a piece of technology that tells you where are you at the specific time. It tells you a ranking, which is you can start like, give us 1, 2, 3, 4, or 5 stars, depending on what you like pizza, Peter Piper pizza, right? 5 stars, 4, 5. Would you mind to give a comment? So all that input that we humans, we're providing to this technology has been stored somewhere, yeah? At the very beginning, it was kind of nice, was kind of interesting. Now they know where you are. now you know that you like pizza, and what time is to go to home, and what time is time to go to the work, and why you're not at your work at that specific time. Hey, today is Wednesday. Why are you not taking pizza? You eat pizza last time. So who is keeping that information? And that kind of forces humans to trying to start to create a model. Yeah, back in the day, we used the computer as a tool. Now the tool is using us a little bit just to keep kind of an interesting discipline of what to do, what to eat, and if you're late or not. And that's some of the problems that we need to start thinking about. What exactly is behind technology? What is exactly behind computer science? And all these attributes that we're actually studying nowadays.
You know, your answer to that question leads me perfectly into my next question, because you're going into the realm of social engineering, of political or social dictatorship of our lives.
Mm-hmm.
So my next question is, are there any dangers that you perceive in the information age that we are all living in? You've already begun answering that question. Can you go into it in a little bit more, the darker area, the real dangers?
Well, we are in dark area, dark side. Wait. Oh, okay. So maybe you thought I was in the not in the dark side.
No.
Hold on.
I mean, knowing that you have to go to work at a certain time and have pizza, I was thinking maybe a little bit darker from that.
So that's a. I was just teasing you. So it's many people might think that because. So there is a misconception. Let me just unpackage a little bit of this conversation, because people say, oh, you're a computer science, you're a hacker, you know how to hack. And that's a lot of the misinterpretations that we always got through time. And there's always a funny version of that, and there's also a very serious version. The interesting thing is that you don't know where that line starts and where it ends. So there is indeed some dangers and benefits, of course, about having this technology and having this information age, because people who use technology, as I mentioned previously, you can use that as a tool, of course. That was the whole intention at the very beginning. There's a cell phone, there's a mobile device, there's a programming language. This will help us to do X, Y, or Z. The question is where you can define those ethics, what is considered to be a good thing or a common good, or the greatest good for the greatest common, or the greatest good for me, right? So there is a lot of questioning nowadays. As a matter of fact, this is one of my research areas, which is cyber ethics. I've been studying cyber ethics for many years now. They're taking a lot of impact in social media. I mean, we don't have to go very far away. You just have to check the news from the word last month, okay? So every day, if you go right now to your newsletter or whatever you read, or whatever you don't want to read, there's going to be always a news about how information has been modeled for the advantages of someone. And the question is that's so human, and that not even deals with computer science or IT. That's more a human behavior. And unfortunately, some people might think that is the problem because of technology. The reality is humans have to do a lot of that in that part. So when someone uses technology for certain purposes without evaluating the consequences, then it becomes like a danger thing. When someone uses for the benefit for the human or for the greatest good, then you can save lives. You can anticipate problems. You can predict certain things that might happen, and you can prepare people. You can collect data and help the community just to say, you know what, in the next days is not going to be good to go out. And when happens last year, when it happens in 2020, all mathematicians and statisticians, computer scientists, they joined, and there was a task force where they put all this data about COVID, for example, and they put in the data and said, you know what, this is an exponential situation. And for those who don't like math, this is when you probably regret. I have a couple of mathematicians here in the group, is when math is very useful, because you can probably distinguish between a linear function and an exponential function. And when you see that it's an exponential function, that is very dangerous to be outside. I'm talking about how the virus is being spread. So it's obviously an exponential thing. It's not like, well, eventually it will kind of go away. It's exponential. It's very hard to come up with those things. we would not be able to see that kind of visualization if we wouldn't have all this collaborated work between statisticians, computer scientists, mathematicians, social behavior, social scientists, I'm sorry, to see how the human behave and how everything is going to take place. That's why the models, they came out very handy. That's how the predictions came out very nice. And that's why they use what we call the supercomputers in order to predict what's going to happen, and also to try to come out with a nice vaccine, for example. In the other hand, when you probably reverse engineer, because you mentioned something about reverse engineering, you might want to have a target in order to solve or in order to attack it, and you just reverse engineer how things we would it be. And that's where the problem right now comes, because if I use all this information that statisticians or computer scientists they use for my benefit, then something might happen for my benefit, and that's who is making those decisions. And that is the question: is this part of is this a private sector? If it's maybe a public sector, but has to be transparent, but to certain level. Is this the government? Is this the adversary government, like for example other countries? So who is behind the scenes? And that's where the problematic comes, when you put everything in a plane and it's like, what are the interests for everyone? I don't really want to deviate too much into that part, because your question is, what are the dangers to perceive the information age that we're living in? And the dangers are how you provide that information to everyone. For example, your social security, your date of birth, some indicator that actually identifies you in a community. Those are the dangers, because we don't know who is going to take that information. So after those 4 minutes that I've been talking about, if you just want to keep something from this question, is that be careful how you share your information and to whom you share it, because otherwise you don't know what are going to be the consequences.
Thank you. Dr. Servin, you recently published an article called Challenges and Opportunities During COVID in the Association of Computing Machinery Inroads magazine, about the highlights and challenges that community colleges are facing during the COVID-19 pandemic. Can you tell us about it, please? And I know that I have got some of your visual
visual
to accompany
yeah.
this. Let me just share my screen.
Sure. So I was very lucky to, one of my articles got published in this magazine. It was very interesting that they accept our article it was last year. So it takes time, because this is only get published 3 times per year. And you can go to the next slide, please. It's one of this article. ACM stands for the Association of Computing Machinery, which is the largest international association. Is the oldest, by the way, in computing. So basically all the advancements, all the attributes, all the news and everything that comes in computing has to go through the ACM. So the next slide, I'll talk about this, because it's this is a collaboration that I did with my friend and colleague Kara Tang. Dr. Kara Tang. She is in Portland Community College. She's a computer scientist as well. And it was more about the community college perspective. If you're interested to read the article, you can go to that site that you can see right now. And that kind of gives you an insight. There is a couple articles there, but if you notice in the inroads there, it was the very first highlight in the cover page of that. So we were very pleased and very happy to get that. Thank you very much for those who send me your best wishes and everything for this announcements. I was very excited. If you go to the next slide, I'm just gonna mention real quick about of the challenges. So what makes this article very unique is that I describe, along with Professor Tang, some of the challenges that we're living in right now in the community college. Of course, APCC owns a lot of different challenges, particularly because of the whole area that we are located. So here we're in the border, we have all kinds of diversity in multicultural impact. But we also have this non-resident population, which we have students who are from different locations. We have Fort Bliss here. We have the military students. We have also students who are to be deployed, coming back and forth. So that's actually a very interesting challenge that we're facing. What happened to those students when they leave, and what happened to those students when they arrive? Where is the context on those students. When COVID hits on March 13, when officially actually we went to spring break, we never came back. So there was a lot of challenges there, specifically because we migrate through a face-to-face environment to an online environment. There were so many different questions about how to address information, how to address the material, to see if the student have a laptop they can access. So there were challenges to see the resources, like in computing, and also the food pantry is one of them that we also have some of those concerns. The workforce, the challenges in jobs, there was a lot of difficulty times, and we identified some of them that we were facing, and in those days that we're still facing some of them. Some of them, they've been mitigated a little by little. And one of those challenges was probably students, they don't have resources. And I know the college did a great job by using a lot of different resources, including the CARES grant, which basically you provide some kind of assistance to the students, but also the IT department provide laptops, a lot of different resources like hotspots and whatnot. So there was also the equity challenges. Not many people have internet. Not many people have a computer. Not many people know how to use a computer. Even in computer science, you might think many people you're studying computer science, you know how to deal with this. In reality, no, because in computer science, we deal not only that you have a computer, but you also have different type of computers. Some of you have a Mac, some of you have a Windows or a PC, and you have different operating systems. So there is difficulty and non-uniformly how you're gonna actually teach in the classroom. So those were challenges that they actually were impacting our students, and currently they're still impacting our students. Tutoring was a different situation. When we were in the classroom, everything, the instructor, we have this ability to see the immediate feedback if the student got a problem or not. If the student is challenging about how to solve a problem, how to compile the program, you can see it right away in runtime. In online, it was a different kind of situations. I answer probably more than 200 emails per day for my students. Some of them, they're repeating questions. Some of them, they're the same students, but my email is always 200 at least, lower bound. But the tutoring is being very effective as well. So we kind of brought this idea about how to help us students in tutoring and the peer leaders. I know there is a lot of efforts in tutoring. EPCC is great on that. And of course, we have to deal with the new normal. So it's hard to define the new normal. I know it's like the term that everybody is using right now, the new normal here, the new normal there. Reality, you need context to define a new normal. The new normal is right now, we are an online environment, and we're trying to go back to the face-to-face environment with the precaution, to be cautious. But in reality, the new normal has been always the normal. There's students who don't have computers. There's students who need help. We need tutors, right? And we need assistance for all these different kind of capacities. But defining a new normal might be a challenge in education, but in reality, it's just a reflection of a lot of the things that they were missing beforehand. Can you please go to the next slide? I think that was the challenging part that we were facing. But having in this kind of situation, it brought a lot of opportunities. For example, professional development. There's a lot of opportunities to increase your professional development as an instructor, as an educator, also as a student. I mean, I have been in a lot of professional development since last year, and I'm trying to learn new technology, new modalities, new best practices about how to teach online. There has been a lot of different work that is being doing by other colleagues around the world that they can help us to identify challenges that we're gonna anticipate that's gonna happen to us. Maybe we are facing challenges that people need to know. So those are the situations that we want to know. I remember when I have worked with Blackboard in the past, but I remember when this thing happens, I went to Luz Cadena's videos that she did for you can see emergency 101, because how to create a shell, how to put everything to the shell, that was very, very helpful. And that was professional development. I started to give professional development to my colleagues, to my other computer science colleagues of mine, and that actually is a great opportunity. Also, to see specialized courses that we need hands-on. People say, okay, let's go to online, everybody. Yeah, but wait a minute, we need to actually, there's some certain things that we need hands-on. And that's what there was one of the needs, to see how can we address this hands-on using technology to help the students and for instruction. That was another opportunity. Special education and accessibility. Accessibility. Many people just start recording and posting things, but you don't know the opportunities that you need and you're missing. For example, effective closed captioning. I've been working with Jennifer Dargreen, yeah, from Sign Language, and you got no idea how much I've been learning from her. She just actually told me a lot of different opportunities where we can actually explore, and that's where we've been working with her. It's very important to identify those attributes also for people with who need kind of different capabilities. Standards, plagiarism, and academic dishonesty, that's another opportunity to see where we can improve our pedagogical attributes, because just copy and paste whatever you used to do in the face-to-face environment, it will no longer work. Yeah, especially because you don't really want to, you want to keep a standard. You don't want to lower your standard, but you don't want to just give everything just in order to be an opportunity for everyone to just perform plagiarism or academic dishonesty. So it's an opportunity to see what is the best practice in order to obtain that. And that was pretty much what we obtained from that article. There was a compare and contrast. I gave that link in case you want to take a look at that. I think there's another slide after that. I don't know. I forgot about that. No, that's a different thing. But that's basically what that article.
Dr. Serene, will I go to the next slide after that?
Yeah. I mean, that's your question. I just want to mention a little bit of the other things.
Sure. Well, do you want to go further now with the Allan Turing or not?
Yeah, we can talk about a little bit, because you want to go ahead and tell me. You tell me about something. Your next question.
Okay. Oh, here we are. Who are some of the people you most admire in computer science and information technology? Allan Turing must be one of them.
Yes, indeed. So for those who don't know, Allan Turing is considered to be the father of computer science. And so back in the day, after the Second World War and before the Cold War, there was a lot of pressure. And computer science is fairly new. It's like probably one of the youngest areas of study, right? It's not as old as biology or chemistry, of course, mathematics, right? Computer science it's 50 years old, maybe a little bit more. So, but it's still defining the whole trajectory of computing. But Allan Turing is considered to be the father of computer science, and he started to do things in something called eventually the computer. So he is considered to be the father of computer science. If you haven't watched the movie The Imitation Game, yeah, try to watch it. It's a very nice, I guess, glimpse about what Allan Turing was doing during the Cold War. I think it will give you a very nice perspective. I already say Cold War, it's the Second World War, one of those battles. So that's where computer science was defined. Back in the day, we didn't have a computer, so they used a machinery, right? A machinery just to do the operations by hand. But the algorithm was key there, and he embedded that. If you go to the next slide, I mean, that's a very difficult question. When Richard just asked me about when Professor Barakat asked me about what are the people that I admire, is like it's probably the most difficult question I ever been asked, because, for example, Dennis Ritchie, he's the father of C and Unix. Everyone who has anything, like right now we have a computer in front of us or a mobile devices, is thank you because we have a programming language. It can be Java, it can be Python, it can be something else. But before Python, before Java, before everything else was an operating system. Before an operating system was a very native programming language. He is the founder. He created something called C and Unix. That is basically the root of all the fields of computing. So he's considered to be the father of all the programming languages and everything that actually runs in your machine. You probably say like, oh my God, right? Steve Jobs. I don't know what are your other heroes, but they do the interesting thing just behind the scenes that Dennis Richards was doing back in the day. He actually created a programming language that interacts with the machine. Yeah, so he's basically who needs to get all these attributes or all this elevation about who did what. Can you please go to the next slide? Oh, Dan Knuth. He is one of the basically big founders of Art of Computer. He wrote the Art of Computer Programming. If you don't know what the Art of Computer Programming is, an encyclopedia basically that comes with all of the algorithms that have been implemented. But he has done a lot of different things. He did also LaTeX, which is the scripting that we do in order to write effective text editors and text documents, sorry. So he's probably all of these are genius, of course, but he's basically who create most of the advances in computing since the last century. So he's great. He's still an emeritus professor at Stanford University. So this guy has been amazing. And he wrote also Concrete Mathematics, which is a great book in order to recognize series and sequence of series and application of those series. But he started writing on a magazine called Math. Probably you remember MAD, right? So that's where he started to write on those things. So he's a big character, great collaborator to the computer science community. Next. Of course, we have Grace Hopper. She is a U.S. Navy, she was a U.S. Navy Rear Admiral and the creator of COBOL. So it's very important to recognize the big effort that Grace Hopper did. She was in the Navy, right? But she was, back in the day, there was a lot of technology, a lot of different computers and with very complicated things. And she decided, you know what, I'm going to create a programming language that looks like English, because all this coding for me is, God, no. It has to be simple, it has to be clean, and I'm gonna do that thing. But Grace Hopper has a lot of stories about how all the great effort that she did, especially for women in computing. This was a great admiration to push women in computing. Back in the day, even right now, there's very little women in computing, and she's one of the big influencers in order to get computing, women in computing. She did a lot of work. She was recognized because she was recognized. Sorry?
Sorry, no, she went to my college, Vassar.
Oh, yes. And she's, if you read her biography, I recommend to everybody to go see. You will see a lot of interesting stories. As a matter of fact, the word debugging, have you ever heard about the word debugging? Or when you have a bug in your system, she was the one who introduced that concept of bug in computer science. It was very funny and very interesting because one of the machines that it was misbehaving, back in the day, ladies and gentlemen, we didn't have a laptop like that. We didn't have a machine. We have a room where actually you put some cards, they're stamp cards. That was the program that makes the computer to execute a lot of things. And one day something was weird. It was a bug. It was an actual bug inside of one of those cards, which actually make it misfunction. The word debugging is being attributed to her because she introduced that word debugging or bugging there. It's very funny. If you go to even Wikipedia, you will find a lot of great stories. I was lucky enough to work with a lot of colleagues who actually were working under her her research and the attributes. And every time I have this opportunity to talk with them, especially in the Northeast, when you go to Baltimore and everything, their friends, they still there. I always try to visit it because it's fascinating how influential she can be for these new generations. I think we have a couple more. Allan K. So he's from California, right? This is one of my favorites because I was lucky enough to meet him and have some kind of conversations with him. He's considered to be the father of object orientation programming. He created object oriented. If you don't know what object orientation programming is, you can see Java, C++, Python, like all these contemporary programming languages. He invented a paradigm called object oriented. And the reason why he wanted to do that is because he wanted to teach kids how to program, like playing a guitar, because he plays a guitar and the piano and whatnot. And he wanted to put it in a programming language so kids can actually program there. So he is probably one of the most influential persons that I ever know. And I was lucky enough to meet him once, and we share a couple of thoughts with the Starbucks. I remember that. I can't remember when was it. I think it was in Baltimore. I cannot remember. Can you go to the next slide? Professor Krenovich. We are very lucky to have him at UTEP. As a matter of fact, this is the main reason why I decided to stay in El Paso. When I went to my graduate studies, I wanted to study uncertainty, artificial intelligence, to work in interval computations. And Professor Krenovich, he is the most represented, internationally speaking, the person in dealing with artificial intelligence and interval computation preliminary and fuzzy logic in many different areas. I was very lucky to work under his research area, and he's here at UTEP. So I still collaborate with him. We're still collaborating and working in research together. He is an outstanding person, great human being. So he's one of the persons who has influenced me a lot. And of course, Lathi Sadeh, the father of fuzzy logic. This is, by the way, this is the area where I did my PhD. He's from Azerbaijan, yeah, and he's considered to be he's the father of fuzzy logic. If you don't know what fuzzy logic is, instead of dealing with 0, instead of dealing with 1, we deal with everything else. It's just a matter of degree. So it's based on the matter of expert who say this is cold, this is not so cold, is warm, this is not too warm. So every time you want to deal with imprecise information, you deal with fuzzy logic. Fuzzy logic right now is one of the indispensable and critical components of artificial intelligence in order to make a decision. So fuzzy logic is one of them. You go to the next slide, please. And here is me, right? This is Professor Sadeh and Professor Krenovich down in the lower right. I was honored that they went to my talk when I was in San Diego. That's in San Diego in a couple of years ago. And then up there is Allan K, who is the father of object-oriented. And to the left-hand side is Mark Allen Weiss. I'm just hanging this book, right? That's the textbook that I use in my data structure class. And great people, great humans.
It's wonderful you're able to meet and collaborate with them at these conferences.
I agree. I've been honored, and I think I've been very lucky, Professor Barakat, to be living in these exciting times where I'm like a groupie, to be honest. It's like I'm following them. Like, oh, I know he's gonna present in this conference, and then I go to that conference. And even sometimes I just try to publish something in that conference. If it gets published, good. If not, it doesn't matter. I'm just gonna go there and just try to see and ask them, because those are great influences in the contemporary areas that we're living right now, like artificial intelligence, machine language, and other areas that is very, very important. So I try to follow them, and notice that I'm trying to follow it in the good sense, just to learn from them, yeah, and after that trying to work in something related what they've been working with, yeah. Oh, this is one of the great experience. I was in the news in Russia. This is the what is this called? International Symposium on Scientific Computing, Computer Arithmetic, and Verified Numerical Computations. This was in Novosibirsk, Russia, in 2012. I was so lucky to see all that group that you see there. It was a lot of scientists and engineers around the world. We met just in order to create, it was a conference. My article was published in this symposium. And the news, I don't know what they really say because it's in Russian, but you can see my face there in the news there. So I was in national news there because we met there. I was very honored to, one of my papers got published there back in 2012, and I met a lot of interesting people who have influenced me nowadays. So that's only just something that I wanted to share there with you all. Okay.
Well, my next question is, and it relates to your slide, What are some of the advances that are being made in computer science and information technology that are really opening up the field for this new century?
And that's something that we often get nowadays. If you go to the next slide, it's we can see that right now computer science, of course, computer science and IT is still the core. Computer science is the core of all the emerging areas, right? So IT, we use a lot of information technology tools in order to right now we're using IT. We're using a Blackboard in order to establish this connectivity and whatnot. Computer science has been the emerge. So right now, my students every student that I have, I always tell them stay in computer science. That actually gonna help you to at least to know how to program. And right now we can go to something you call data science and analytics. Right now it's so popular. Right now we can see a lot of social sciences, weather prediction, stock marketing, also the new missions that people are doing to Mars. It's they're very useful to have data scientists because you want all the information that is right there, all the data that is right there, you want to give in a meaningful way. That's why data sciences and analytics are emerging right now. Machine learning and artificial intelligence, that's probably one of the most popular venues that we're facing right now, because this whole decision making that we need to develop, or we need to consider before we alternate to a decision, we use these machine learning models in order to make them learn and make better predictions. Quantum computing, it's another area that is becoming more powerful and more popular, especially because there's some information that we need to know and predict, and we cannot do it through these computers. We need a supercomputer or a quantum computer. Of course, we don't have quantums. Los Alamos, they have one, but there's for other purposes. Cloud computing and internet or Internet of Things, it's another emerging area that is being actually been popular for a while now. I wish I could have more power in order to obtain what they need to do it, but right now the other areas are emerging, but still very popular because everybody has a smart phone, smart car, smart microwave, smart everything. The point now is trying to connect them together in order to make them most effective in energy consumption and whatnot. And of course, adversarial computing, people call it cybersecurity. There is still there, very popular right now because of the whole situation that is being happening, the hacking and whatnot. So those are the areas that right now are advancing in computing, just to let you know. I think that's what I have for that.
Our last question is, what is your outlook on the 21st century from a philosophical perspective with regard to computer science and information technology? So the emphasis here is on philosophy of this particular field.
Yeah, and that's a beautiful question, because most of we're done with this slide. If you want to keep it, that's fine. Most of the areas that, as I already mentioned previously in other questions, we have a lot of decisions to make. Yeah, and thanks to technology, we were able to solve problems that in the past they were a little bit complicated to complete, but now we can do it. But we're in a different area right now because now there's a lot of consequences, like ethical considerations and obligations. Now that you know how to solve this problem, what are you going to do with that information? And ethical consideration or ethical obligations, they strictly belong to philosophy. As a matter of fact, these conversations that I have with a colleague of mine, Crisol Escobedo, she's a good friend of mine and a great philosopher. I think we're very lucky to have her in the college, and she can explain this even more in detail. There is work that we have to do in terms of computing in order to relate those with those ethical obligations. Not only that, now with artificial intelligence and machine learning, there's models who actually they're learning from humans. Yeah. It's very sad what I'm saying right now, because we create something to help us and now we're helping them in order to understand us. So we can see how those models can be a little bit more philosophical, because now the machines are learning from us, from all the things that we like, all the things that we share, the things that we don't like, the things that we hate, the things that we kind of laugh about it. I'm talking about those emojis that you click on on your social media, you're kind of classifying the things for the machine. So the machine can say like, oh, this definitely Servin likes. Oh, this hates. Oh, this makes him cry. This makes him laugh. This hugs, right? So those kind of things, you're helping the machine to understand an approximation how you feel. It's like, oh, but that's not true. Well, it's not true, but it's true at some degree. And that's where some of these philosophical questions that you need to start asking is how you're gonna feed the machine in the next time you go to Facebook or Instagram or something like that. Problems that back in the day about the separation of mind and body, now we can see it through virtual reality. People, this is a very big problem in philosophy back in the day. The separation of body and mind, you might think is two different things or only one thing, or one needs another thing. Virtual realities solve that problem. You're physically there, but virtually you're in somewhere else, and you're living in a different dimension, in a different reality. So also augmented reality. Aspects, for example, that relates with what's considered to be private, what's considered to be transparent. We need transparency because that's the way we actually need to know if someone wants to attack us. Well, we need privacy also. The problem is that privacy is not, even that is somewhere, the notion of privacy in the Constitution is never a strict definition what privacy is. And that gives us a lot of ambiguity in the way when we create programs. And that is a very interesting philosophical problem where we do belong to that. And there's other problems like how to make recursive problems in real life and make it robots or machines adequate to help us and not to destroy us. And we need to be very careful about that because in the computer programming, we can create a couple of those rules to say, use this rule in order to do this. And the computer is going to obey what those rules is. And as a humans, we need to be very careful how to react because if we don't satisfy one of those rules, then we might be ended up to be a target for the computer. And that's where those lines have to be defined in the future generations. And that's my 2 cents on that comment.
Well, that's much more than 2 cents. And before we open up to some questions, we only have a few minutes. It's absolutely fascinating, your talk today, Dr. Servin, the insight and the analysis that you've brought to this important subject for us all, whether we're computer science majors or not. I'm not. I come from the other end of campus as the English department, but I find more and more that the questions and answers that you've discussed today speak to my situation as well as Crisol, whom I happen to know well, who's a philosophy professor. And the way the disciplines interact at this time is extraordinary to me. So we just have about 5 minutes left. I want to open questions up to the audience. You can use the chat or even use your microphone. It's up to you. Questions for Dr. Servin. Robert Nosvich, Professor of Government. Rob?
Yes, hi, Dr. Servin. This is Bob Nosvich, Government Lecturer. Earlier when Mr. Bearcat was showing the slides, I noticed that all of these people had one thing in common. They were all Anglo, and all of them except for Grace Hopper was male. My question for you, sir, is do you find more women and more racial and ethnic minorities going into this field to possibly become pioneers in their own right, or is that pace not fast enough so the world does not continue to be dominated by Anglos in this field?
Yeah, that's a great observation, and that's always an interesting perspective to see from what is the context of that. I have seen, and thank you so much for your question, Bob Nosvich. So one of the things that I have seen lately is that there's an emerging more diverse community approaching to the computer science community. Of course, especially right now because the whole advances, you see a lot of people from Latin America, you see a lot of people from India, from Asia. So there's a lot of different right now communities emerging. You mentioned Grace Hopper. She's only one of the very, very small amount of women who actually contribute to the field. As a matter of fact, I was debating between put in Grace Hopper or Ada, who was a mathematician back in the day. She's considered to be the very first computer scientist. She created the abacus back in the day. I know abacus, like the thing from kindergarten. Yes, she was actually the one who created the abacus, and is considered to be the very first computer scientist. That's a great honor in order to have her. Just type Ada on Google and you will find. But going back to your question, it is indeed an interesting observation that now is getting diverse. As a matter of fact, I serve for a couple of committees from the computer science area, and one of the committees that has been emerging is diversity in computing, and it's a little bit interesting to see what's considered to be diversity. In reality, I don't want to see it that way, because there's a lot of people from different places who have been contributors to the education, at least in computer science education. And it's getting more and more, and I think it's more because we have this flexibility nowadays that you can provide online courses and everything is virtual. We all behind the scenes, but it's getting right now. It was a little bit shocking if you just go back a couple, even maybe 30 years ago, that you can see a very common denominator in that community. Now I think it's been changing. It's not too much, but it's still getting there. Talking about diversity, many people might think community colleges, we consider to be also a very small amount there in the computer science education, but still we're growing. And that's something that is one of my missions that I want to see, is to form community college education in computer science. And this is what I've been doing for the past 10 years. That's how active I've been doing in all these committees and those conferences. So community college is considered to be also some kind of involvement in the computer science education community. That's a great question.
Thank you. It's 2 o'clock now, everybody, and I have to be a little bit strict today because I have another meeting. So I know that some of you are, or many of you are in Dr. Servin's students. So I hope that you'll be able to ask him questions when you meet again, if you have any. But I want to thank everybody for coming this afternoon, and of course, Dr. Servin most of all, for a truly fascinating and entertaining and beautifully eloquent experience about the nature of computer science, information technology, and its philosophical effect upon our world today. I've learned so much. Thank you again, Dr. Servin, and thank everybody. And we'll be advertising the next meeting of minds and community and announcements. So keep an eye out. And thank you for coming and have a great day, everybody.